Okay, so welcome, and now we're going to talk about the cosecant function. So just like the secant function is a reciprocal function for cosine, cosecant is a reciprocal function of sine. So we can gain a lot of information from looking at the sine function very similarly to the same way we looked at the cosine function for secant. So you can see that here, again, you're going to have vertical asymptotes where the sine function crosses the x-axis because it's a reciprocal function, cosecant is undefined when sine is 0. So that's where the asymptotes are going to come in. Okay, now, in this time, the asymptotes are coming in at powers of multiples of pi. Okay, so so what you can see here is this is shifted over, right? Just like sine and cosine are shifted over by 1/2 pi, so is secant and cosecant for obvious reasons. So we can see that the cosecant function is just the same as the secant function, but it's shifted over 1/2. That's why when we were talking about the secant function, the period was, or not the period, but the domain was x not equal to pi over 2 times the absolute value of b times an odd integer of k. So times an odd integer, so some odd multiple. Okay? Now, why? Because it was shifted over 1/2. Now that it's shifted over 1/2 for cosecant, now everything lands on multiples of pi. So that's why this happens, again, assuming the most simplest part is where b is 1, right? So we get multiples of pi. Okay? So this is the general case. So the domain is all real numbers except x is not equal to multiples of pi over the absolute value of b. Okay? The range, of course, is the same as the range for the secant function. And this is an odd function. Why? Because sine is an odd function. Okay? So this is also an odd function. The period, of course, is 2 pi, assuming that if b is 1. So we see that we've got, in this case here, one whole cycle is 2 pi. So we represent in the general case, p is the period p is 2 pi divided by the absolute value of b. Okay. Let's see. Yeah, that's it. So yeah, so you can get the idea. So again, just like with the secant function, you can see that as the sine function goes down, it's above, this goes up. So again, the same behavior as we've seen with the secant function. It's just basically shifted pi over 2. Okay? Okay, that's it. Have a great day.